So the effect of the hinge on the internal force then is as follows. No matter what you have on the left and on the right side of the hinge, you will always have a moment diagram that passes through zero at the hinge. So for example, if I have a distributed force here, and maybe a concentrated force here, and who knows what else happens in the system, but then my diagram must pass through zero at the hinge, as mentioned many times before. But everything else that we learned before is still true. So here I have a load case, I'll call it W, and that load case is effectively a constant, right? It's a constant load case, constant evenly distributed force, and then I have zero and a concentrated force. So this is concentrated. And then whatever else happens on the system we don't care about right now. However, we also have still the same rules that apply, and that is that if you have a constant load case, your shear force diagram must be linear and your moment diagram must be parabolic. So I have no idea in this system what's happened to the left and to the right of it, but let's just pretend for a second it is parabolic here. And so it goes somewhere, has a maximum, and then it has to pass through zero here. And then, because on the right side of the hinge now, the shear force would be a constant, it must be linear. The moment diagram must be linear. And technically the slope at the hinge continues, right? So the slope in this point from the left to the right is pretty much the extension of this line, or the line is the tangent, and then due to that force there, either it goes back up depending on what happens on the right, or it continues to go down. But that's not the point here right now. The point is really what's going on here at the hinge. Your moment diagram must pass through zero at that location. There's no way around that. And everything else still applies. So now we know what effect the hinges have on our internal force diagrams. I only drew the bending diagram here because it really only has an impact on the bending moment diagram and on no other diagrams. As you can see here, there's still a value for V and a value for N, so don't get confused when you see a hinge and you draw your diagrams. Only let your moment diagram go to zero. But now we are ready to actually apply this knowledge because everything else stays the same, and we can solve our first internal force problem for a hinged beam.